Would you like to reminisce about our collaboration?
Our collaboration. Actually, there were two stages. I think a minor stage, which, since we're talking about it, the minor stage was the inequality of the vector-valued version of the maximal theorem. I had given a course, by the way, which became a little book, which you actually wrote the notes, beautifully written.
By the way, I'll reminisce a little about writing the notes, but go ahead.
Yes. Okay, beautifully written. And in there, I proved some result which suggests a general result about vector-valued maximal functions. And then we started to talk about it, but of course you were so fast, and before I knew it, the theorem was proved. So that I would call our minor collaboration. Now, what was our major collaboration? Now, after your PhD, you spent a year in Princeton as a lecturer, and then you went to Chicago, which was very fortuitous for you. And I remember that you wrote me a series of letters about things you were thinking about and doing, beautiful letters in mathematics. And one of those letters was, you explained that Zygmunt, so that's interesting that it all comes back to Zygmunt, my teacher, who was there, had asked you a question which was, if I remember the question correctly, is what, in one complex variable, what is the dual space to H1?
Well, no. Okay, this.
Please correct me.
He asked, is there a non-trivial characterization of BMO in terms of the Poisson integral?
Okay.
So not just that on every radius that the BMO norm is uniformly bounded, but something more serious like the area integral or something.
All right. Anyway, that is makes the story even more interesting. So Zygmunt had asked Charlie a rather provocative question, and Charlie thought about it, and not only did he solve that question, but he realized that on the basis of that, one way to think of BMO is as the dual space of H1. And so he wrote me one letter, maybe it was two letters. And of course, I had been very interested in H1 and in HP because of my earlier work with Guido Weiss. And so immediately I became interested, and we started to collaborate. And then, I don't remember exactly what year that was, but at about that time, which was either 1970 or 71, we both spent some time at the Institut Mittag-Leffler in the spring. And then we talked about it a great deal. In the meanwhile, there had been some work from a probabilistic point of view by Burkholder and Gundy. And so all of these ideas were there, and then we worked on the theory of HP spaces, and we wrote this paper, which was published in the Acta and was one of my very nice collaborations. That's
definitely one of mine. I remember the same thing. I just want to add that a crucial ingredient that went into the ideas in that letter to you was a remark that you made in a paper of yours in which you remarked that BMO was a very interesting class of functions, and if you apply a singular integral to a bounded function, that's in BMO.
Right.
And so before that, there was this interesting class of functions, and they were in the exponential class. Isn't that striking? Isn't that useful? But this gave a completely different point of view.
Right. There was another thing that was very important to me that I had observed before your work on BMO, which then became part of our work, and it was understood better, was that if you took the standard class of singular integrals and applied them to L1, they did not preserve L1. They mapped L1 into H1. But if you applied them to H1, they preserved H1. And that was the dual of a statement that if you applied singular integrals to BMO, that was in BMO, which was a stronger version of that remark, which I hadn't proved, but somebody else had proved.
Let me also just tie up our collaboration with something that I mentioned earlier, the optimism. I remember we were working together, and we needed some inequality of Hardy and Littlewood, and we couldn't remember the proof, and we couldn't find the reference. And I remember very clearly you're saying, you know what, okay, damn it, if Hardy and Littlewood could prove it, so can we.
Now it comes back to me again, and I know which inequality it is. It's the LP inequality for p less than 1, for a harmonic function in the conjugate if you integrate over the south thing. Yes, what I meant by that, I didn't mean that I was as good, maybe you were as good as Hardy and Littlewood. What I meant is that given what we know nowadays, if they could do it then, in the more primitive time, we should be able to do it now.
But it's optimism.
Yes.
You know, we can do it.
Yes.
That's
Yeah,
powerful
right.
medicine.
Right. No, that I will admit. Yes, that I will admit. Yeah, but optimism has to be part of the kit of any successful working mathematician, because you're always up against things which look hard before they're done, and then they look easier.
Yes. Yes. Oh, let me just reminisce to you about the experience of taking notes from that course. So first of all, there was a team of students taking notes from this course, at least initially. I'm not going to mention names. The lectures were so beautiful, and the notes, when I got them from the other students, were far from beautiful.
I would imagine, because I've gotten notes before.
Okay, and I took it on myself. I think I'm generally a gentle person. I kicked them off the project, and so you can. I think if you look carefully, you can see the first half of these notes are incredibly careful, and the second half I think are good, but not quite as careful, because I think it was Eugene McCarthy who was campaigning for president, and I spent lots of time knocking on doors.
Yes, but they're beautiful notes. I've never seen notes. I mean, they were finished, I made a few little additions and a few little changes, small changes, but they were beautiful notes. They were beautifully done.